As a software engineer, chances are you've crossed paths with MongoDB at some point, whether you're building an app for millions of users or just figuring out your side hustle. It's the most popular non-relational database. MongoDB is intuitive and incredibly easy for development teams to use. Now, with MongoDB Atlas, you can take advantage of MongoDB's flexible document data model as a fully automated cloud service. MongoDB Atlas handles all the costly database operations and admin tasks that you'd rather not spend time on, like security, high availability, data recovery, monitoring, and elastic scaling. Try MongoDB Atlas for free today. Visit www.mongodb.com/cloud to learn more. That's mongodb.com/cloud. This is Scott Hanselman. This is another episode of Hansel Minutes, and today I'm chatting with Adam Barr. He's the author of The Problem with Software, Why Smart Engineers Write Bad Code. You worked at Microsoft for many years, didn't you, sir?
Yes, I worked there for a little over 23 years in two different stints, 10 years and then 13 years as developer, dev lead, dev manager, and then a couple other jobs.
And you've since escaped and are consulting and hopefully enjoying yourself.
Yeah, so there's things I miss about Microsoft, but overall I'm happy to have a little more flexibility in my schedule.
Well, when you took a sabbatical, you went off and wrote this book, The Problem with Software, and I was fortunate enough to get an early copy, and I'm on the back of the cover there with a little quote about why I think this book is great. And one of the things that I said about it was that it was an unflinching view of what sucks about software and how you can potentially solve it. It's a really dense book, and I say that in the kindest way of the word dense. There's a lot of information shoved into 300 pages in this book.
Right. The idea was I wanted a book that was readable by a non-programmer, but also could be read by programmers. So the non-programmers would get some insight into what was going on with programmers. And the programmers would hopefully get a little self-reflection about what they could do better. So my concern was that I'd make some comment about one example was I'd say, well, a byte is 8 bits. And then some programmer in their mind would jump up and say, well, no, actually, there's this example referenced in the original KNRC book where a byte is 9 bits. How can you say such an uninformed statement? So I tried to put the details like that, proving my programming chops, into the endnotes because the programmers will read those. And then the regular people will just skip the endnotes and hopefully get a little more of a story without all these random tangents explaining these really esoteric details about stuff that only a programmer would care about. I'm trying to avoid the situation. When you read a book about programming, Clive Thompson just came out with his book Coders, and I was leafing through it, and even just reading it, he's not really a programmer. And you see these things where you grit your teeth and you're like, oh, that's not quite accurate. Even though I understand for a wide audience, that's what you got to do. So I tried to be accurate where possible. And that does lead to some digressions and tangents just to really explain, well, this is actually what the real story is.
I'm actually going to have Clive on the show in a little while, and I'm quoted multiple times in the book. And even though he had a fact checker, I spoke to him at length. I spoke to his fact checker at length. There's still a number of times, and I was like, oh, that's not exactly how I would have phrased that.
The one I saw, there's all these people talk about bugs in software, and they're kind of merging together an actual bug like Heartbleed where the programmer made a mistake, and then things like the 737 MAX 8 problem, which is really technically not a programmer bug because the system is working as designed. It was just designed badly. And then you got problems like the Ericsson certificate problem last fall that knocked out some cell phones. And people call all those things bugs. And then he's trying to give an example of a bug, and he gives a Python syntax error. And it's like, that's not any of those. That's not at all what we're talking about. It's not a logic bug or a design bug or an operational bug. It's some minor thing that gets cleared up quickly and never affects any code that's checked in. So I was trying to be, hey, I'm actually a programmer. I do understand this stuff. When I try to explain it for a layman, at least I'm not making some basic mistake of miscategorizing something that would grate on a programmer's eyeballs.
I was trying to explain Meltdown and Spectre, the Intel CPU exploits, as they're not really a bug, as they were, like you say, a design flaw. I was trying to explain them for the layperson, and I said, well, imagine that you are thinking about going and spending some money, and by virtue of the fact that you thought about looking in your wallet, I stole the credit cards out of your wallet. Because you're doing a predictive, there's two parallel universes, one where you left and opened your wallet and went off and did it, and one where you didn't. And by virtue of the fact that you thought about it, I've stolen your money. And people either think that's a perfect analogy, or they spend the rest of the day ripping the analogy apart as a wholly and completely imperfect analogy. There's just no good way to make analogies around code.
Yeah, honestly, that analogy you made has some flaws, which, never mind. Honestly, I heard about that and I thought, wow, that is really clever. Occasionally you have to sometimes you look at an exploit and you're like, wow, just to think of that and realize you could use cache speed to predict stuff and realize what the processor had done as they got more complicated. It was actually pretty darn clever.
Yeah. And you refer to the software sausage and how it's made, and what's clean and what's not throughout the book. And one of the things that you call out kind of early on is the education of a programmer, and whether or not we can catch these things early, or maybe some of these bugs in software are really bugs in how we teach software.
Yeah, I think the problem is you can learn to program on your own, and a lot of people do. This really started once the personal computer became widespread and people could teach themselves to program without going to work for a company or go to college, which is where the computers used to be. And people taught themselves, and then they went to college and kind of used the same skills they taught themselves. And universities weren't really teaching the actual mechanics of writing code. They tended to teach algorithms. And so people were basically all self-taught. Even if you nominally had a software engineering or computer science degree, you actually had taught yourself to code. And you had taught yourself on very small programs, maybe with a couple other people working for 3 months on some assignment in class. And that is vastly different from what you do at a large company where the software has to persist for years and it's multiple people working on it, multiple groups, it's stitched together with APIs. The frustrating part of all this is IBM and other companies figured this out in the 1960s and wrote a bunch of books about it, but that was essentially ignored by all these self-taught people in the late 80s and early 90s because they could be successful with their self-taught methodology. So you really wind up, and it's still today, that it takes a while working in industry for people to hopefully figure out, API design is very important. It's not some afterthought. Stitching these things together is really what matters, not just cranking out some code in my office. And Microsoft certainly, despite that being known and ignored, they spent a long time figuring out things, for example, that you couldn't test in quality, you had to design it in. I heard Jerry Weinberg state that Charles Babbage, working on the difference engine 150 years ago, stated that you could not test quality in, you had to design it in. So it's not like it's a new idea, but people keep having to rediscover it on their own at great cost of time and frustration.
Mm-hmm. So let me ask you this tough question, because as I'm going to refer to you and I as senior developers, and that could be a double entendre in the use of the word senior. How do we make sure that we as senior people are not gatekeeping and preventing younger people or self-taught people from being successful? Like, there is this knowledge out there by virtue of the fact that they're either self-taught or learned at a code camp, or maybe just learned at a university that didn't teach them these things. How do we set them up for success when we bring them on our teams? Certainly, we don't want them to simply not get involved in tech in the first place. We want them to be successful.
Right. It's tricky to avoid being the grumpy old person shaking your fist at those kids today. I think the way I learned, and I started out, I had a job before Microsoft, but my first real serious software development was at Microsoft, and I happened to be on the Windows NT team under Dave Cutler. And luckily, that was just the way things were done. You did do design work You really did worry about quality. You tried to avoid being careless. That was the in the air in the group. And so I think what's important when people come into existing team out of college is just to say, look, this is what we do. Acknowledge that the people are smart and they can write code and they could probably debug small bits of code, but in a gentle way explain that industry software is different because of the scale and the time that it has to last. And there's certain ways we have to operate. Despite that, your first code review will be hard to take for anybody. It will feel like personal criticism, no matter how much you're prepared for it. I wish universities did code reviews. They had students doing code reviews of each other's code, both for the educational aspect and also just getting used to it, that's part of working in software, is other people have opinions about your code and you're not the one software genius in the world.
That is hard to take that feedback, though. Like, you have to be able to take, like, I used to say, like, my code doesn't suck. So my code sucks, rather, I don't suck, right? It's like when you write your first essay or your first poem or anything, you put a piece of creativity out in the world and it's suboptimal. It doesn't work for whatever reason. Not attaching your ego to what you wrote is challenging for anyone, especially a young person.
Right. I think especially if you're in software where you've sort of succeeded without really having to learn a lot from other people and get feedback. I think in other industries, certainly other engineering disciplines or areas like medicine, you're learning from other people all the time. Mm-hmm. Nobody goes through a medical program thinking, oh, I know everything about medicine. I'll just keep doing what I did in high school. So they've already been taught that, yes, you have to learn. You have to stand on the shoulders of giants. And I think I made an analogy in software. It's more like we're maybe getting a little boost onto their big toe or something. And most stuff is just relearned by people rather than having this understanding that that's the way the world works. You learn something from other people.
Speaking of old people who shake their fists, you mentioned Edgar Dijkstra in the book, and you talk about in 1975, he said it's impossible to teach good programming to students who've had an exposure to BASIC. They're already mutilated beyond hope of regeneration. That's a little bit rough. I certainly hope we're not doing that today with JavaScript or other languages that are more accessible.
Well, every time I make a comment about a specific language, somebody yells at me, so I'll refrain from that. But Dijkstra was really saying, the quote is a good one about BASIC because, well, Bill Gates' first language was BASIC, so isn't that funny? But the timing's actually important. It was 1975. It was the year that Microsoft was founded to market a BASIC interpreter. And Dijkstra was really trying to tell people languages like BASIC as they existed back then, not Visual Basic, which is somewhat modern. Those languages, they didn't have block if statements. They were riddled with go-tos out of necessity. The subroutines didn't have parameters. They were terrible languages. And he was saying there are actually better languages. Algol in particular was a pretty good language, and it's really the ancestor of C and C# and Java and most modern languages. He was desperately trying to tell people, stop learning BASIC, stop learning Fortran and COBOL as your first language, use better languages. Unfortunately, it was just the wrong timing. The PC industry was happening. They all used BASIC as their built-in language because you could fit it into a 1K ROM or something. And so they went with BASIC. All these people bought their PCs, taught themselves BASIC, and maybe they weren't mentally mutilated, but they certainly learned some very bad habits. I once had an argument with somebody about, well, it was my sister actually, about how you didn't really need parameters to methods and you could use a line number instead of a name. I mean, you understood it, right? And that's just a classic kind of thing you say when you've only worked on small pieces of software for yourself and you've never worked on something big. Because if you're writing a small piece of software for yourself, any language is fine, essentially, because it doesn't matter how readable it is. You understand it. It's when other people have to understand your code that something like old school BASIC really becomes problematic.
Mm-hmm. She's a programmer too, your family of programmers?
Well, she's actually not a programmer, but she was taking a programming class in college when I was a high school senior.
Uh-huh.
Arguing with my sister is probably not the place where I applied the most logic to my arguments. I was probably mostly interested in proving her wrong, so I adopted this sort of ridiculous attitude that IBM PC Basic was a good language.
Your code is powerful, and so are you. And when you consider the reach of your code, it's clear that to deliver quality code, you must also deliver secure code. So where can you start? A first step is educating yourself on basic secure coding principles and beginning to put these principles into practice every day. Vericode's Secure Coding Toolkit is your go-to resource for all your secure coding needs. The benefits of the toolkit include learning best practices for secure coding, understanding how to secure your DevOps environments, and learning to combat the most common software vulnerabilities. Stay secure and download this valuable asset today at veracode.com/toolkit. That's VERA code.com/toolkit. You also talk about the difference in programmers of different eras and what they worry about, and you point out that the programmers of your era worried about the efficiency at which their programs run. And I remember myself reading the book Programming Pearls, which is a collection of columns from Carnegie Mellon computer science professor, and it seems like I hear, at least amongst applications that are commercial applications, less and less about the concern around efficiency. Are we getting away with a lot because processors are so powerful and memory so plentiful?
Well, we probably are, and I think that's fantastic because when you worry about performance, you almost certainly make your code more complicated and harder for other people to understand. When I was teaching my kids to drive, I said, the number one way to drive safely is not to be in a hurry, because when you're in a hurry, you take shortcuts and you're not your best driver. It's the same thing with designing software. If you're worried about performance, it sounds like a noble thing, and maybe you could even conceptually say, and there's a couple examples probably where, I removed the code and it was simpler and it ran faster, but that almost never happens. Worrying about performance means putting in some side channel or adding some weird API parameter that kicks in some behavior in certain situations, and just generally writing more code to handle the common path separately from the error path or whatever. Just it winds up with less understandable code. And so the fact that people can not worry about it in most cases and just write clear, simple code is actually a great thing. Again, when Bentley was writing Programmer Pearls, that was a long time ago, and you did have to worry about performance more. But even he said, although Programming Pearls is mostly about performance, even he said, don't do this stuff all the time. This is for the situations where you need to worry about performance. You can use these techniques, but don't just go blindly trying to make your software fast, even though it feels good. It's like scratching an itch and it's easy to measure. You made something 5% faster. Figuring out that you also made it 100% more complicated takes longer and involves other people and more time, which are not something programmers generally want to deal with. So they can just sit there over-optimizing something all day and feeling virtuous when in fact they're probably not helping anything.
Well, certainly making it, what's that old saying, right? Make it right and then make it fast?
Yes, I like Knuth's quote about premature optimization is the root of all evil. And I've simplified that to say optimization is the root of all evil. Not that you should never optimize, but a lot of bugs are there because someone was optimizing something and they, like I said, made the code more complicated or just had a bug. Programmers like to write caches. Again, caches seem like a clever thing, but there's a lot of bugs in the cache itself, which only manifest because you tried to make the thing faster and often without really knowing if that was important. And until you get something in front of a customer, you don't really know if this thing needs to be optimized. And today, with stuff in the cloud and the way you can scale so easily and storage is basically free and CPU is so cheap, a lot of times you don't have to worry about optimizing it. You just throw some more hardware at it.
You know, it's interesting that you point that out because I've got a blog system that I worked on. It's called Das Blog, DAS, like it's German for the blog. And it's been running for 14 years, effectively unchanged. But I have a couple of bugs that I hit probably once or twice a month, as well as a lovely bug that I hit every time we fall back, because the software never expected that time could go backwards. And they're all caching related. And I probably didn't, I did it because 15 years ago we had less processor power than we do today, and I could probably turn the cache off and the thing would work a lot more reliably. Virtually every bug in DustBlog is a cache related bug.
Yeah, I'd say within a rounding error, if someone suggests a performance optimization, you should say no. You'll be right enough that, well, the couple cases where it's probably a good idea you can deal with. But I think, as I said, it's a programmer instinct, and you've got these old timers grumping about kids today. But I think there's far more important things to concentrate on, in particular, making code that's maintainable and readable.
Well, I appreciate that. Like we can joke about old programmers saying kids today, but what do you think kids today will get from a book like this? There's historical context, I think. You talk about the importance of agile and when these things started and how it fits into how we make software today. What do you think that a 20-year-old would take away from this book as they are learning about things like agile and learning about things like design thinking?
Right. Hopefully they'll get the understanding that something like Agile is useful in certain situations, but not all situations. And that language they like is good in some situations, but not other situations. So just be a somewhat skeptical consumer of programming wisdom. They have likely very limited experience. They don't have the broad exposure to a bunch of different languages, a bunch of different code bases. And so they may, based on their own experience, think that something is the right way to do something, but that may or may not be true. And I think it's easy to kind of float through a CS undergrad program on your own wits and never really come to face with the fact that other people actually are smart too. And your favorite language may not be the greatest language, that kind of thing. So just an appreciation that they might be suffering from a little bit of hubris as they approach work in an industry, and those old grumpy programmers may have something to teach them.
Yeah, I as someone myself who used to teach computer science at a state university, at least, I always felt like there should have been a historical context of computer science or a history of computer science, and like let's learn about programming, because I feel like I'm learning more now in 2019 about the history of programming from tweets, where I learn about what Ada Lovelace did, or what, or seeing a movie like Hidden Figures, and I go, oh wow, I didn't realize that that's how that was done, because no one ever taught me this in school. I don't know did you have a history of computer science course?
We had zero history, and I went to school in the 80s, so a lot of this there was a lot of empirical studies done in the 70s. People actually studied commenting and variable names and method length, all this stuff that's just sort of debated endlessly now with no resolution. They actually studied in the 70s, and that wasn't that long ago when I went to school, but we heard nothing about it. It was just, here's some algorithms, now go write a compiler and figure out, here's the book about, here's KNR, go teach yourself C, kind of thing. And that was what I heard from other people. It wasn't just where I went to school. And so, yeah, there was really nothing historical. Sort of time began when Unix was created, maybe. And
didn't it literally begin though? I mean, technically it kind of begins at that moment, right? We know when zero was, right?
Right. Yeah. That was essentially the message we got. C was the first programming language ever. The first decent programming language ever.
It did feel like that. Like for people of a certain age, they did kind of imply that like C was the first language ever of any import. Here's the KNR book. They hand it to you. And, by the way, there's this assembly language, but we only have to do that for one semester.
Yeah, it really was. I mean, literally, somebody asked in class as we were discussing our first programming assignment, because they were one of the rare people who hadn't taught themselves to program in high school, said, well, how do I learn the language? And they said, oh, well, here's the book. Knock yourself out.
Those were the days. So you were at Microsoft through Windows NT, through 2003, and a lot of bugs started showing up. Slammer bugs, Slammer blaster worms. Like 2003, 4, 5, people were slapping Windows NT and Windows generally around pretty hard, were they not?
Yes, we did an attempt to eradicate the bugs it had to be before mid 2000 because that's when I left the NT team. That's when I left Microsoft the first time. So that was where they actually sat down and explained about buffer overruns and exactly how you could construct an exploit using a buffer overrun, which again to me seemed, wow, that's really clever. But then of course it was my software they were attacking, so we had to fix it. But we did it with code reviews, and we didn't have the SAL, the annotation language that would attempt to track some of these C problems across function calls, so you could actually get some sense of what was safe and what wasn't. And I think Jim Alchin made an unfortunate comment to the press that, oh, we found all the bugs and fixed them. And then of course you had Slammer and Zotab and Blaster.
Because he believed that there was an automated tool that could find all buffer overflows.
I think he just thought you could find it by code reviews, and I mean, finding stuff by code reviews is really a classic testing and quality approach. I mean, Eric Raymond was running around claiming that open source software is more secure because there were more eyeballs looking at it, which is just completely not true. You make things more secure. We saw that
with OpenSSL.
Right. You make things more secure by engineering in certain techniques to avoid, in this case, since C is such a terrible language, for buffer overruns, there's techniques to avoid it. Or you could not write stuff in C. That would also work, but that might be a bridge too far for some people. But it was. I don't think my code ever actually had an exploit directly in my code, but I mean, I was writing code that faced the network, that manipulated buffers received off the network. So, I mean, I could easily have had an exploit that was directly in my code.
Did people keep track of stuff like that? I mean, does it really matter whether it was in your code or were there collective code ownership? Were people, running blame and saying, look, it was Adam?
They wouldn't run blame. I think it was, and maybe this is being too forgiving, the attitude was, well, C is hard, and I think that was general attitude. Even when the first
C is hard, yeah.
The first Morris worm came out in 1988, which was the first remote C exploit, the attitude was, well, you can't protect against everything, sort of, attitude. I mean, I was talking to a guy who actually worked in the trustworthy computing team, and they had some analysis of all the major exploits and who had done the actual check-in. Again, I don't think they were going to blame people. It was just, okay, maybe there's something on this team. And he had the actual name of the person who'd done the check-in. And I sort of said, well, has anybody on that list twice? And he sort of laughed. And then we ordered the Excel by user ID. And there was somebody who had actually managed to check in 2 exploits, or the code behind 2 exploits. And was like, what would happen to that guy? And we looked him up, and of course he was now a director of development somewhere at Microsoft. But that's an amusing story, but that doesn't mean necessarily he was a bad programmer. I mean, I think we all could have made mistakes, but he just happened to have made 2 of them.
Well, certainly. I mean, let he or she who has filed the first bug throw the first stone. I mean, anyone can make a bug like that. You can fat finger something, and off by 1 errors are the bane of the entire internet, aren't they?
Yeah, there's a lot of Unicode. Putting Unicode into the guts of NT was a great thing because it meant you could handle all these languages, but there was a lot of these exploits that were just messing up the wchar, the number of 2-byte characters versus the number of bytes needed to store it. And so you had a lot of these. It wasn't off by 1, it was off by a factor of 2 mistakes, and you just tried to copy a 256 Unicode character buffer, which is 512 bytes, into a 256 byte stack buffer, and the thing would overrun. And
I remember those days.
You're
It
off
was
to the
very
races.
difficult. I remember as everything was switching over, and we were in school, it was baked into our brains that 1 byte equals 1 character. And then one day, 1 byte equals 1 or less than 1 character, or a fraction of a character, or the beginning of a statement that there might be characters coming. And UTF-8 got in headers, and all these things became complicated. And suddenly we were counting bytes in one hand and counting characters in the other hand. And it took quite a few years before everything shook itself out.
Right. I actually walk through this in some detail in the book because I think it's important. I'm trying to explain why C is a bad language. And hopefully I'm not losing all my non-programmer readers, but it really comes down to just making a math mistake. And I mean, you can do it right. You can write buffer manipulation code that is not exploitable. I think the fact that people use the term virus makes it sound like, oh, you can't necessarily defend against it, but you can write clean code. It's just a little tricky to do.
Mm-hmm. Yeah. You called out a couple of other things that reminded me of some bugs that I had. Like you called out the Turkish code page and the concept of code pages where we had 256 characters and we were trying to map other characters on top of those. I remember one of my big bugs that actually I still may exist in my blogging software is the legendary Turkish I, where they have an I, the letter I with a dot above it. And when you capitalize that I, it turns into a capital I with a dot above it, which is not a capital I. It's a Turkish capital I.
Yeah.
And when you make comparisons and things go bad.
Yeah, that's another example I actually dig into in my book a bit because I'm trying to explain about it's an API. You call an uppercasing API, or maybe you call a comparison API, and you have to make sure you do them properly. And I'm just trying to explain that, again, API design is really important, and understanding an API is critical, and that's really somebody not exactly understanding what their API does. And in this particular case, I wind up railing against default parameters, which I think are really a scourge on programming and should be removed because you have to make an assumption about what the caller of the API wants, and I think that's a bad idea. And yes, you can save a little typing with a default parameter, which saving typing is bit of an obsession among programmers, but if it leads to a bad bug, it probably isn't worth it. So I don't like default parameters on APIs.
Well, there's a ton of great stories in the book, and like you point out, it is accessible. This is not a book where one page is full of code and the other page is full of discussion of code. It is definitely readable by the non-programmer. It's not an overwhelming bunch of curly braces that's going to stress you out. It's really a fun, smart tour of many decades of experience from yourself and others. And I appreciate you coming on the show to chat with me about it.
Thank you so much for having me.
You can check out The Problem with Software, Why Smart Engineers Write Bad Code. It's available now from MIT Press, and I'm going to have links to it in the show notes. This has been another episode of Hansel Minutes, and we'll see you again next week.